solving one variable equations using addition, subtraction, multiplication, and division. So this is a review of how to solve an equation, just the very, very basics and sort of the concept behind why we do what we do in order to kind of undo an equation and solve for a variable, okay? So we're going to start off first by talking about the basic principle of equality. And so that sounds big and scary, but every one of you already knows what this means. And so you've heard your teacher say a million times that if you add, subtract, multiply, or divide, it doesn't matter which operation you're doing, but if you do add, subtract, multiply, or divide one side of an equation, then you must do it to the other side. Okay? Now, you've all heard that 100 times before, right? We say that to you over and over again. So if I'm adding 6 to this side of the equation, what do I need to do? Add 6 to the other side of the equation. The idea is that you're always keeping the equation balanced, right? Keeping it equal to each other. And the equal sign is there to kind of remind us of that. And so it's like the middle of our balance scale. And you're going to see me draw balance scales a lot in my equations just to remind you about how to do that, okay? And so the other word you're going to hear me say a lot, and some of you may or may not have heard this before, is a zero pair. And so zero pairs are like terms that have opposite symbols. Okay, so like terms that have opposite symbols or opposite signs. So for example, -3 and +3. So what happens when you take -3 and you combine it with a +3? You get a 0. So we call this a zero pair. If I add them together, I'm going to get a 0. Okay, so another zero pair might be 2/5 and -2/5. Again, +2/5 and -2/5 is going to give me a 0. So those are zero pairs, okay? So let's talk about addition and subtraction. Using zero pairs or inverses, it's another name for these, they're inverses of each other. We're going to use that concept to help us isolate the variables. So the first thing I always ask students to do is find your variables. So there's my x, and I have to undo whatever is happening to that term. So you can see that right now there's an add 3 here. So in order to get the x by itself, I have to undo a +3. I'm going to make it a zero pair. I'm going to undo +3 with -3. Again, there's my balance. So if you do -3 on one side of the equation, you have to do -3 on the other side of the equation. We just said that zero pairs cancel each other out, so +3 and -3 leaves me with 0. So now on the left-hand side of the equation, the only thing I have left is an x. My equal sign stays in its place. And on the right-hand side of the equation, 8 subtract 3 is 5. And so I get x equals 5. Okay, the second equation over here, my variable is right here in this term, so I have to undo -2, and you're going to undo -2 with its zero pair +2. Again, there's my balance. So if I do +2 on one side of the equal sign, I have to do it on the other according to the basic principle of equality. The zero pair cancels, and I get x equals 6. In the third example, we've shifted around where to find your variable. This time the variable is not the first term, it's the second term. So here's my variable, and I always take the sign with it because that positive goes with the x. That's a positive x. What kind of 5 is this? It's a +5, so I have to subtract 5. Again, find your balance. There it is, which means I need to subtract 5 on this side. +5 and -5 cancel. I'm left with x equals -3. In the fourth example, my x term is right here, and here's my balance, and I have to undo a -1. I'm going to do that with a +1. If you add 1 to one side of the equation, you've got to add it to the other. So 11 equals x, or if you really like to have it written in order, left to right, you're going to say x equals 11, same thing. So some very, very basic addition sentences just to refresh your memory, and subtraction sentences. Let's talk about now multiplication and division. Again, very simple ones. We're just kind of reviewing. So let's go over here and start with what is happening. So again, in those last examples, we had things sort of what I call attached to the x that we had to undo first before we could get this term by itself. In this case, the term with the x in it is already by itself. So then the question becomes, does it have a coefficient in front of it or not? The answer is yes, which means it's being multiplied by 4. So if this is my balance scale, and I have multiply by 4, I have to undo multiplication with division. And if I divide one side of the equation by 4, I have to divide the other side of the equation by 4. And so 4 divided by 4 is 1, so I get 1x. You can put the 1 in front if you want to, but you do not have to. That's kind of a silent, it's kind of, I always think about it like the silent E in English class, right? It's there, you don't have to write it, you can if you want to. It's not a big deal. 48 divided by 4 is 12, so we get x equals 12. In the second example, there is a fraction. I know how you feel about fractions, but really fractions are the same thing as division. So note to self, a fraction means division. So how do you undo division? You use multiplication, right? So if you're going to use multiplication to undo it, you have to multiply by whatever is in the denominator that you're dividing by. So we are dividing by a 4. 1/4 means to divide it into 4 pieces. So that means we're going to multiply by 4. So just a little note to self, you're always going to multiply by the denominator. Always do that first, okay? So I'm going to multiply by the denominator over here. Find your balance. There it is. And if you multiply one side of the equation by 4, you must multiply the other side of the equation by 4. So remember that you can take the 4 that you're dividing by, or that you're multiplying by, excuse me, then you can write it over 1 to make it into a whole number, so that 4 divided by 4 is 1, and 1 divided by 1 is 1. So that cancels. Those are reciprocals of each other. They cancel out. They equal 1. You're good to go. So x equals, and 7 times 4 is 28. In the third example, you're saying to yourself, what is that coefficient in front of n? Okay, so what is that? I could rewrite that to say negative 1n equals 25. Some students do that. They like to rewrite it. Here's your balance scale. You are multiplying by negative 1, which means you need to divide by negative 1 to undo what is happening. So those cancel, and n equals negative 25. And then the last one, again, is a fraction. Fraction means division, and you're going to multiply by the denominator. So I'm going to multiply by a 4, and I'm going to multiply by a 4. Again, when I multiply by 4, then these cancel, right? And I get n. Again, here's my balance. I get n on the left, and I get 20 on the right. Okay, so that was just kind of a review of addition and subtraction, multiplication and division. And now if you go to the next page, we're going to do combinations. So we're going to do more than one thing at a time. Maybe not at a time, but in order. We need to do more than one thing. So let's look at this first example. Sort, that means to gather up all of your like terms together, combine them, and then isolate your variables. So there's kind of 3 things to do here. So this is get things on same side of equal sign. And when I say things, I mean like terms, right? Then combine them and then isolate them. So you can see I have my x's together here on the left-hand side of my equation, and I have all my numbers that are by themselves together on the right-hand side of the equation. So sorting is done. Sorting done for us here. Okay? The sorting is done for us. So we're just going to start combining. So 4x minus 1x is 3x. And 7 plus 8 is 15. And now I'm down to a one variable equation that we just talked about in the last examples. So here's my balance scale. And if I'm multiplying by 3 on this side of the equation, then I need to divide by 3 on both sides of the equation. So x equals 5. Okay? Second example, let's see, are all the x terms together on one side of the equation? The answer is no. So I'm going to do this one twice because I want to show you what happens if you were to do this differently than someone sitting next to you. This can happen. So the question is, which of the x terms do I move? Okay, and there is always a better choice. Can you move the 4x or the 8x? Yes, you certainly could move either one, but one is definitely a better choice than the other. Let's talk about why after we're finished solving. So I'm just going to go ahead and move this 4x term. I'm going to sort it, and I'm going to move it to the other side of the equation. Anytime you take a number or a letter and you move it from one side of the equation to the other, you're doing the opposite, right? So I have to undo the 4x over here so that they will cancel each other out and it will be gone on this side of the equation. And if I added 4x to the left-hand side of the equation, I have to add 4x to the right side of the equation. So I get 9 equals, and 8 plus 4 is 12x, okay? And then I need to divide by 12 to get x by itself. So divide by 12, and I'm going to get x equals, okay, so then I'm going to have 9/12, which I think you all can tell right away are both divisible by 3. So if you divide them both by 3, you're going to simplify them. 9 divided by 3 is 3, 12 divided by 3 is 4. So we get 3/4 as our answer, okay? Now, if you had not chosen to move the 4 over here and combine it with the 8, you would have moved the 8 to the other side to combine it with the 4. Here's what would have happened. Notice where my balance is. You're going to have a 0 on this side of the equation, because that's a 0 pair. You're going to have 9 minus 12x. And then you probably would have said, okay, now I need to move the 9 to the other side, right? And you would have negative 12x equals negative 9, and then you would have divided by negative 12, and you would get x equals, I'm sorry, you're dividing by negative 12. So negative divided by negative is a positive, and divide them both by 3 again to simplify, and you would have gotten 3/4. Now, I think most of you would agree that this was the easier way to solve it, okay? So take a minute before you start the process and think about which way would make sense. Since the x's are together over here and the number is all by itself over here, it makes sense to take that guy and move it over there and be with the x's, and then you're already down to this step and ready to go. This one involved much more moving and sorting. Okay, so think about that and make it easier for yourself. Does it matter which side to sort the variables? We just had that conversation, right? And so again, we can show and prove here that it doesn't matter, it just certainly makes it a little bit easier. Example, move the 2x first. So subtract 2x from both sides. So we get 2x minus 8 equals 14. Here's the term with the x in it, which means I need to undo everything that's attached to that term. So I'm going to do the opposite of negative 8 in order to cancel it. 2x equals 8 plus 14 is 22, and then divide by 2. And so x equals 11. Now, instead of moving the 2, let's start off by moving the 4. And you're going to see that clearly one way is easier than the other. So we have negative 8 left over here after my 0 pair is gone. 2 subtract 4 is negative 2 plus 14. And then I need to, here's my balance, subtract the 14. Right? Negative 22 equals negative 2x, and then divide by that negative 2. And so we get 11 equals x. You will get the same answer. So does it technically matter? No, but it certainly makes it easier if you just take a moment to think about which way you're going. Okay? One other thing I want you to be aware of before we finish with this video is what happens when the variables cancel out on you, and what does that mean? Because this happens sometimes and it seems to stress us out, right? If our variables cancel, we don't know what to do and we just kind of give up on the problem. So let's look at this example. First, we're going to combine some like terms just to kind of simplify. 4x minus 3 equals 3x plus x is 4x minus 3. And you'll notice whatever you have on the left side of the equation is exactly the same as what you have on the right side, right? So here's my balance, and I'm going to subtract the 4x so I can move it over here. And when I do that, my x terms cancel, and I'm left with this statement, negative 3 equals negative 3. Okay, now before we even talk about what that means, let's go over here and solve this one. 3x minus 7 equals, combine your like terms, 3x minus 11. Again, there's your balance. Subtract 3x from one side, subtract 3x from the other, and you get negative 7 equals negative 11, which is not a true statement. Okay, so one is a true statement, and one is a false statement. This tells us something about our equation. If you look at this step, 4x minus 3 is equal to 4x minus 3. Would you agree that it does not matter what number I plug in to the left side? Whatever it is, I'm going to multiply it by 4, and then I'm going to subtract 3, and I'm going to do the exact same thing on the other side of the equation, multiply it by 4, subtract 3. That means that no matter what number I put into this equation, this balance scale will always stay balanced and always be equal. That means that every single number that I plug into this equation will result in a true statement. And if that's the case, there are multiple different answers for this particular equation, right? All numbers I plug in here make it true, right? All the numbers make it true. And so your answer is just all real numbers, because there's just too many numbers to write down as possibilities as answers. We could do 5, negative 12, 1/3. It doesn't matter what we put in, it's always going to be true. And in the same vein, in this equation, if you think about this, no matter what number I plug in, I'm going to multiply it by 3. That part stays equal on both sides, but once I get that result, on the left-hand side, I'm going to subtract 7 from that, and on the right-hand side, I'm going to subtract 11 from that. So all numbers, no matter what I put in, make it false. So in this case, there's no way I can ever get this scale to be balanced, because this negative 7 and this negative 11 are different values. And so my scale is tipped and not balanced. And so my answer in this case is no solution. There is no number that I could plug in to x on both sides and have it end up working. Okay, so that's what happens when your variables cancel out. No big deal. It just either means your answer is all reals or no solution. If it's a true statement that you're left with, it's all reals, and if it's a false statement, it's no solution.